Let's now look at how we can price swaptions under the standard market model. Now here we have, for example, an option to enter into a pay fixed swap. So let's set it up. So we have a swaption that gives the holder the right to enter into a pay fixed swap at maturity time t. The underlying swap has a swap rate of SK. So you'll be paying SK in exchange for floating rate. The swaption has a maturity of n years, but within each year, you make m times of a payment in a year. So let's say you have a 5-year swap and quarterly reset. So in this case, there are 4 payments each year, and for 5 years, so altogether there are 20 different reset periods. Now, the swap has a notional of L, and if the swap rate at maturity T is ST, basically the realized swap rate is ST, then essentially the swaption then provides a payoff of this. So you are pay fixed for float. So the swaption you pay SK, but you receive ST, and you do a max here and multiply by notional, but the rate needs to be divided by M because you have M times per year, and all the rates are expressed in terms of annualized rates. Okay, so this is basically the setup for the swaption. And to look at a graph here, so initially we have some time 0 that we're interested in the price of the swaption, and the swaption matures at T, and for each of those periods is where the payment's gonna be provided. Well, at this point there will be a swap exchange. Either you'll get a swap or you'll be out of the money, and you don't have to settle physically. So if you settle physically, you are in the money, you'll get that particular swap. But if you get 0, or if you settled financially, then you just get the difference of that payoff. But if you look at it, you can think of as if when you settle, there'll be a swap. The swap is actually, fixed here. You get the payments from here, here, and here, and here. So this is the first year, and then starting from this point on, and equal to 2, okay? And if we assume that the swap rate, what we call the forward swap rate, follows a log normal process with a volatility parameter sigma, and also you will have a whole bunch of discount factors, a term structure of 0 rates that will be a price starting from here for a period to any of those. So for each TI, there's a discount factor here. So if that's the case, and we can price our swaption using the Black's model in this way here. Now, later on, we're going to justify why this is the case, but let's just first look at the formula here. So essentially, for a swaption that we pay fixed for float, where give us the right to pay fixed in exchange for floating rate. Sorry, it's a swaption where the underlying swap is a pay fixed swap. Then the swaption will be priced as follows. the price is related to the notional L, and this A here is really the annuity factor here. Is annuity asset here. And here is this whole set of zero coupon bond, one for each TI. I is from 1 to M times N. So you have quarterly payment, 5 years, so there'll be 20. So TI will be from T1 to T20. And this S naught is the forward swap rate at time 0. And D1 and D2 are calculated this way, okay? Whereas K is the strike price. And you plug in this formula here, you will be able to calculate the value of the swaption. Now, the key thing here is, we must have the initial, the forward swap rate at time t equal to 0 is equal to the expected realized swap rate at maturity t. And this expectation is given by using an annuity, which is this A here, as the numerator asset. And we're gonna see why this must be the case.